here is the question for multi-channel, that is Abel-Baker problem, and the question is consider Abel-Baker table. Inter-arrival time having equal probability ratio 1 to 6 minutes apart. Able service time have equal probability ratio from 1 to 5 minutes, and Baker service time have equal probability ratio 1 to 4 minutes, and random digit for time between arrival is given here, and random digit for service time are given here, and Able is faster than Baker. Okay, before going to the solution, we just count the number of random digit for service and arrival and write down the number of random digits for arrival are 1, 2, 3, 4, 5, 6, 7, 8, 9. They are total 9. And random digit for service time are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We know that we need to consider 0 for random digit for arrival. Okay, so considering 0 here, then the terms will be 10. Now the random digit for arrival and random digit for service time are 10, so they are equal, so we are not excluding the any term from the arrival. Okay, now moving to the solution. This is the first step in solution, that is inter-arrival time distribution table. Here we need 4 columns and the customer's number can be known from the question, that is inter-arrival time having equal probability ratio from 1 to 6 minutes apart. So we are writing 1 to 6 here. Okay, and the probability is 1 by 6 for each customer. So the decimal value of 1 by 6 is 0.16. So we are writing 0.16 for all the customers. And now the cumulative probability can be calculated as cumulative probability is equals to probability plus previous cumulative probability. So keep the first probability value as the cumulative probability as the same. Okay, so 0.16, we are putting 0.16 here. Now just add these two values, 0.16 plus 0.16, that will be 0.32. Same, just add these two values, you will get the result. Okay, continue for the other values. And next, for the random digit assignment, just keep the values which are after the decimal at the right side of the random digit assignment and create the intervals, that is from 1 to 16, 17 to 32, 33 to 48, 49 to 64, 65 to 80, 81 to 96. Okay, now the second step is service time distribution table. In the question they are given service time for Able and service time for Baker is separately with the separate probability, so we are considering the separate table. Okay, now the probability is given for the Able is 1 by 5, so the decimal value of 1 by 5 is 0.20. So we are writing 0.20 for all the 5 customers, and calculating the cumulative probability and random digit assignment, same how we are calculated in the first step. Okay, same with the Baker also, the probability here is 1 by 4, so the decimal value of 1 by 4 is 0.25, so we are writing 0.25 for all the customers. Okay, now moving to the next step, that is third step, determine inter-arrival time. Now random digits are given in the question, so we are copy downing that values. We know that for the inter-arrival time the random digit should be always considered as 0, so we are putting dash here, and how many number of random digits, that many number of customers we need to consider. So 1 to 10 here, and inter-arrival time can be calculated as the first is 0, so put it as a dash, and next take the value that is 62 and go to the first table for inter-arrival time. Check where 62 lies. 62 lies in the 4th row, so the value here is 4. So continue for the other values, you will get the answer. And next, for arrival time, just keep the first value as it is, that is 0, then add these two values and put here, add these two values and put here, add these two values and put here, you will get the results. Okay, now for 4th step, to determine service time, that is random digits are given for the service time, so we are writing those values and we are calculating for service time for able. I am considered the two tables separately, so we are considering two tables separately. Okay, now same, take the value 59 and check where 59 lies in the able and baker. Okay, 59 lies here in the 3rd row for the able, so we are writing 3. Now for the baker also it is in the 3rd row, so we are writing 3 here, and now we will choose this one. Okay, now we are taking 83, take 83 and check where it lies here. In the able it lies for the 5, so 5th row, so we are writing 5 here, and for baker it is lying in the 4th row, so we are writing 4 here. So continue for the other values, you will get the result. Okay, now the 5th step, that is simulation table. The arrival time we are calculated in the previous steps, and service time for able and service time for baker also we are calculated in the previous steps. Okay, now time service begin. Okay, first remember that able is faster and the priority for able is higher than the priority of baker. So now for the first customer arrives at 0, that he will go to the able first, check whether he is free. Yes, he is free, so the time service begin is 0 here, and service time for the first customer in the able table is 3. Okay, so we are writing 3 here, then time service end will be 3, that is 0 plus 3, that is 3. Okay, the first customer will not go to the baker, so we are writing dash here, and the caller delay means customer waiting time. The customer does not wait, so the value is 0 here, and idle time should not be considered for the first value, so just put time service and for the first customer the value for idle time is 3. So don't use the formula for the first customer. Okay, just keep the value that is time service and as a idle time. Okay, or the next you can use this formula. Okay, now for the second customer the arrival time is 4 and service time is 1, and the time service end will be 5, that is 4 plus 1, 5. The second customer will not go to the baker, so dash here, and caller delay, the second customer will not wait as he arrives at 4, the time service begin at 4 only, so we are writing caller delay as 0, and idle time can be calculated using the formula, and you can add one more column, that is time spent in a system. This time spent in a system, just use the formula, that is service time plus waiting time. We'll get the, I don't have the space, so please you just add that row column also. Okay, and use the formula, you will get the results. And Next, for the third customer, he arrives at 10. So the times service begin at 10 only because able is free. So he will provide the service. And for the fourth customer also, fifth customer also, and sixth customer also. Now for the seventh customer, the arrival time is 20, but the able is not free, so he will move to the baker, and the time service begin at 20. So we are writing caller delay as 0. And for the eighth customer also same situation. Next, for the ninth customer, the arrival time is 27. So the able is free, so he will move to the able only, not to the baker. So dash here. Next, same with the 10th customer. Okay, thanks for watching, and the notes are available in my blog, so please visit my blog.